We want to do a matrix multiplication between this matrix and this matrix. Now, before multiplying matrices, or really doing any linear algebra operation, we have to make sure that the matrix sizes are appropriate. This has 2 rows and 2 columns, so it's 2 by 2. This has 2 rows and 3 columns. It's a 2 by 3 matrix. These inner dimensions have to match before we can do this operation. So since this matrix has 2 columns and this matrix has 2 rows, the inner dimensions do match and we can do the process. When we multiply these together, the result is going to have this many rows and this many columns. So our resulting matrix from this product is going to have 2 rows and 3 columns. The element in the first row and the first column will be the sum of the products of the elements in the first row of the first matrix times the first column in the second matrix. This element will be 2 times 1 plus 1 times 2. 2 plus 2 is 4. That element goes there. To get the element in the first row and the second column, I multiply the elements in the first row of the first matrix times the elements in the second column of the second matrix. So 2 times 0 plus 1 times -1 is -1. The element in the first row of the third column is 2 times 2 plus 0 times 1, which is 4. Now we go to the second row, which is the result of the product of the elements in the second row of the first matrix with the various columns in the second matrix. So 0 times 1 plus 3 times 2 is 6. That goes there. 0 times 0 plus 3 times -1 is -3. 0 times 2 plus 3 times 0 is 0. And this is our result. Now we want to multiply this column vector, which has 3 rows and 1 column, times this row vector, which has 1 row and 3 columns. The inner dimensions of the matrices match, so I can do this process, and my result will be a 3 by 3 matrix. So the element in the first row and the first column is just going to be 4 times 1. There's no other elements to sum up in that process. The first row of the second column will be 4 times 3, which is 12. First row, third column is 4 times 2 is 8. Moving down to the second row of this matrix moves us to the second row in the column vector. 2 times 1 is 2, 2 times 3 is 6, and 2 times 2 is 4. Third row is -1 times 1 is -1. -1 times 3 is -3. -1 times 2 is -2. This is actually called an outer product, which is the result of multiplying a column vector times a row vector. Now I want to take the transpose of this matrix. This matrix has 2 rows and 3 columns. Since a transpose just exchanges rows and columns, my result is going to have 3 rows and 2 columns. The first row of this matrix just becomes the first column of this matrix, so it's 4, 0, -1. The second row of the operand matrix becomes the second row in the output, 2, 5, 3. It's as easy as that.